So in this video, we're going to talk about how to use the sum or difference of cubes to factor polynomials. So here, let's see what happens when we multiply x plus 2 times x squared minus 2x plus 4. You can see here I've used the distributive property to expand out this polynomial. And then what I've done here is I've rearranged my terms so that my like terms are together. So minus 2x squared and plus 2x squared will cancel each other out, and plus 4x and minus 4x will cancel each other out, leaving me with just the sum of cubes, x cubed plus 8. So that's how we get this factoring pattern. If we have a plus b times a squared minus ab plus b squared, that equals a cubed plus b cubed. So I know that we have a binomial times a trinomial, so there's a lot of signs in this problem. Well, we have this mnemonic SOAP that helps us remember the order of the signs. So if we're looking at a sum where we have a plus sign, what's going to happen is this first sign will be the same. That's what S stands for. The second sign will be opposite. And then this sign will be always positive. So that's what the SOAP stands for in SOAP. So let's look at what happens if you multiply x minus 4 times x squared plus 4x plus 16. So you can see here that I've done the distributive property and expanded this out. And then when I combine my like terms, my plus 4x squared and minus 4x squared will cancel each other out. Similarly, my 16x and minus 16x will also cancel each other out, leaving me with x cubed minus 64, which is the difference of cubes. So that's where we get the factoring pattern. A minus b times a squared plus ab plus b squared equals a cubed minus b cubed. We can still use that mnemonic SOAP to help us remember the signs, because you can see here the sign is negative. So this one will be same. The second sign will be opposite. And the last sign will be always positive. Okay, so that's how we can get this factoring pattern. So if you can't remember cubes, which I know we don't use cubes as often as squares, I have included this chart in your study guide, so make sure that you use this to help you out. It can help you recognize perfect cubes in the expressions that you are trying to factor. So how do you find the cube root of a variable term? Because to use this property, we're going to need to find cube roots. It's going to be similar to what we did when we did square roots. So to take the cube root, you just take the cube root of the coefficient, the numerical part, and then multiply the power of the exponent now by 1/3, okay? Because that's going to be the same thing as finding the cubed root of something. So if we do, for example, the cube root of y to the 6th, that's going to be y to the 6th to the 1/3 power, okay? Remember when we do the power of a power, we multiply the exponents, so this is going to become y squared, because 6 times 1/3 is y squared. Let's try 8y to the 12th. Well, if we take the cube root of that, we're going to equal to the cube root of 8 times y to the 12th to the 1/3 power. So the cube root of 8, if we use our chart to help us out, that's going to be 2, because 2 times 2 times 2 is equal to 8. And then y to the 12th to the 1/3, well, 12 times 1/3 is 4. So this is going to be 2y to the 4th. So when we're factoring the sum or difference of cubes, we're going to start off by factoring out the GCF if there is one. Then we'll check to see whether the first and last term are perfect cubes, and we'll take the cube root of the first term and the cube root of the last term. Then we'll write our factors using the sum or difference of cubes. So let's try factoring x cubed minus 64. So notice that 64 is one of our perfect cubes. So we're going to use that to figure out our factoring pattern. So here's a cubed, here's b cubed. So a is going to be the cube root of x cubed. Well, that's just going to be the 3 times 1/3, so that's going to be x. B is going to be the cube root of 64, which is equal to 4. Okay, so now we have a and we have b, and since here we have a difference, we're going to use the difference of cubes. So we just go ahead and plug directly into that formula. So that's going to be a minus b, so x minus 4 times x squared plus x times 4 plus 4 squared. Okay, so let's just simplify that. We have x minus 4 times x squared plus x times 4 is 4x plus 4 squared, which is 16. So that is how you write this out. And if you want to, you can try multiplying these two expressions together and see that it does in fact equal x cubed minus 64. So now let's try factoring this expression. So we have 8x cubed minus 27. So we have a cubed minus b cubed. So a is going to equal the cube root of 8x cubed. So the cube root of 8, we can get that from this chart here. The cube root of 8 is 2. So we have 2 and then x to the third, and then we take 1/3 of that. So that's just going to be x. B is going to equal the cube root of 27. And notice from our chart that the cube root of 27 is 3. So we have b equals 3. So we're going to go ahead and plug directly into this formula. We have a difference this time. So it's going to be 2x minus 3 times 2x squared plus 2x times 3 plus 3 squared. So that's going to be 2x minus 3 times 2x squared is going to be 4x squared plus 2x times 3 is 6x plus 3 squared, which is 9. So that is going to be our factored expression. So now you can go ahead and pause the video and try doing this example on your own. So in this one, we have 64y cubed minus 125. So the cube root of 64y cubed is going to be 4y. So that's our value of a. The cube root of 125 is going to be 5. So that's the value of b. So when we plug this into now the difference of cubes factoring pattern, we get 4y minus 5 times 4y squared plus 4y times 5 plus 5 squared. So that gives us 4y minus 5 times 16y squared plus 20y plus 25. So if an expression contains two perfect cubes that are being added or subtracted, you can use the sum or difference of cubes to factor.